Welcome back. The objectives of this video are to do some more samples on applying transformations and another sample of a transformation of a rational function. Here in example 8, we're given a function and we're asked to write the equation for the graph of this function that is a multiplicative transformation by a factor of 3. So multiplicative transformation, we're just looking for 3 times f of x is going to equal our new function k of x. So k of x will equal 3 times 2x squared plus 5x plus 8. So we distribute the 3, and k of x is equal to 6x squared plus 15x plus 24. In sample 9, we're going to go ahead and we're going to apply some transformations and figure out what our function might look like. So we're given some x's and y's here, and we're given g of x, and we want to find g of negative 6. But we're going to start by doing a horizontal dilation by a factor of 3. So horizontal dilation, if you think about it, it's going to stretch that graph horizontally. So we're not going to go up as high as quickly. So a factor of 3 is a little misleading here. We think we might multiply by 3. But actually, a dilation factor of 3, or a horizontal dilation of factor, is changing b to be 1/3. So that is going to impact our b of x. So we would say g of negative 6 equals a times f of 1/3 of x, and our x is negative 6, because what's the value of g of negative 6? That's where I get the negative 6 from. Plus some value c. So we've got our b value of 1/3. That's how we're going to start. Now we also want to do a vertical dilation by a factor of 2. So g of negative 6 equals our vertical dilation is our a value. So our a is 2. And then f of 1/3 times negative 6, that's f of negative 2 plus some value c. So I can go to my chart now, and now I know f of negative 2 is 12. So I'm going to do a vertical translation by 5 units. So our c value is 5. So g of negative 6 equals 2 times f of negative 2 from my chart is 12 plus 5. So g of negative 6 is equal to 24 plus 5, or 29. In sample 10, we're asked to write the graph of f of x of this rational function. And if we remember from our past video, 1 over x is our function that looks something like that. So what we've done, this looks a lot like 1 over x, but it's just been shifted 2 units to the left. So this f of x is just 1 over x plus 2, because we have a vertical asymptote at negative 2. And our domain then is all the x's from negative infinity to negative 2 in union with negative 2 to infinity. And our range is all real numbers except 0, because I've got a horizontal asymptote at 0. So that would be negative infinity to 0 in union with 0 to positive infinity. And there's a look at our graph with the asymptotes drawn in for you. In B, we're asked to use the grid to sketch a graph of g as a transformation of f. So our new g of x is going to be negative 2 times f of x minus 4 plus 3. So let's take a look at what that might look like and find out what g of x is. So g of x is going to be negative 2 times f of x minus 4. Well, f of x is 1 over x plus 2, so f of x minus 4 is 1 over x minus 4 plus 2, and then plus 3. So g of x then is equal to negative 2 times x minus 2 plus 3. So our transformations here, the negative will reflect across the x-axis. The 2, or the absolute value of 2, will be a vertical dilation by a factor of 2. Let's see, the negative 4 will be shift 4 units to the right, and the positive 3 will shift 3 units up. So we're going to take our graph from A, and we're going to do all those things and take a look at what that looks like. So our vertical asymptote shifts 4 units to the right, so I moved from a negative 2 to a positive 2, and our horizontal asymptote shifts 3 units up. And that does make sense, because as x gets really big here, this value's, the fraction is going to get closer and closer to 0, and our horizontal asymptote is 3. Now our graph is going to flip quadrants, if you will. We were in quadrants 1 and 3. Now our graph is going to be in quadrants 2 and 4 because we're going to reflect across the x-axis. So that's how we're going to, that reflection will do that. We've talked about that earlier. But let's go find our x and y intercepts here, and then we'll graph. So for our y-intercept, I'll put 0 in for x and solve for y. So I get negative 2 over negative 2, which is just 1 plus 3 is 4. So our y-intercept is going to be at 0, 4, and that'll give me the graph in our second quadrant. And then when I find the x-intercept at something 0, then I'll be able to do my graph down in the fourth quadrant. So I set my output equal to 0. I subtracted 3 from both sides. Once I multiply both sides by x minus 2, my notes are going down into the next sample problem here, but we get, is that negative 3x plus 6 equals negative 2. Negative 3x equals negative 8, and x equals 8/3. So my x-intercept is at 8/3, 0, so 2 2/3, so I plot that. And there's my bridge over the x-axis, so I take it. And there's the graph of my function. And now I can wrap up by stating the domain and the range. The domain is going to be all real numbers except positive 2. The range is going to be all real numbers except 3. And we'll write that in interval notation. So in interval notation, there you go. The domain is from negative infinity to 2 in union with 2 to infinity. And our range is from negative infinity to 3 and union with 3 to infinity. Sample 11 asks us to find the vertical and horizontal asymptotes for each of these functions. A little bit of practice of things that we've already put into place in previous videos. So our vertical asymptote, we're just shifting 3 units to the right. So we have a vertical asymptote at x equals 3, and our horizontal asymptote is at y equals 0. The limit as x approaches positive and negative infinity is going to 0. In sample B here, we have a vertical asymptote at x equals -4. We're shifting 4 units to the left. Our fraction as x gets really big is going to get close to 0, -5, so our horizontal asymptote is going to be y equals -5. In C, the denominator becomes 0 when x is equal to 5, so that's going to be our vertical asymptote, and our horizontal asymptote is, again, the constant at y equals 3. And in sample D, our vertical asymptote will be at 12, and our horizontal asymptote will be at 4. So that wraps up our extra samples on transformations of rational functions, and we're writing equations based on graphs, and you'll get some more practice with this when I see you in class.